Hi, welcome. This is 516 and I'll be treating a particular question on a battery reactor. So the question says, how long will it take to obtain 80% conversion? So this means your XA is equals to 80%, 0.8. Whose in a battery reactor whose rate R is given by minus RA prime. Now the prime here is telling us that we're dealing with a catalytic based reactor. The Na over dt W. This is also the same thing as minus dc over dt is equals to k prime ca. Now this is settled. Now from our previous knowledge, we understand that time to calculate for a batch reactor is equals to ca naught integral dxa over minus ra. I'm dealing with a catalytic based reactor, so instead of minus ra, it becomes minus ra prime. So I have T is equals to Ca naught integral dxa over minus Ra prime. Do not forget this is for catalytic based. Catalytic. Now after this is gotten, I can then say and impute my values to get what I'm looking for. I'm looking for the time here. I have Ca naught from the question. I was told that Ca naught is equals to 2 mole per meter cube. I was told that K prime is equals to 0.4 meter cube gas per kilogram second. Okay, then finally I need Ca, because from here this means that T is equals to Ca naught integral dxa over K prime Ca. That's from this relationship I established earlier. Continuing with this, that means that I have T is equals to your Ca naught is 2 mole integral dxa over K prime is 0.4. Alright, 0.4 times Ca. Now we all know that Ca is equals to Ca naught into bracket 1 minus Xa. I'm assuming that it's not a variable volume here. That's why I have Ca naught 1 minus Xa. Right, so I have this times Ca naught 1 minus Xa. Okay, now after this is settled, I can then say that my T is equals to 2 over 0.4 times 2. This Ca naught is the 2 initial concentration, and I have 0.4. Because they are constants, I bring them out. So integral dxa over 1 minus Xa. Now I'm integrating from 0 to Xa. Please take very good note of your limits. They're very vital in the integration process. This becomes T equals to, these two cancels out these two, so I have 1 over 0.4 integral of 0 to Xa. I have the Xa over 1 minus Xa. So this becomes 1 over 0.4 into bracket. If you integrate 1 over 1 minus Xa, you have minus ln 1 minus Xa. This from your normal integration rule. Now do not forget you are going from 0 to Xa. I have this to become 1 over 0.4 into bracket minus ln 1 minus Xa, alright, minus ln 1 minus Xa, 1 minus 0 now. Okay, what I simply did here was that I took note of the limits. The first one is Xa, so I have minus ln 1 minus Xa minus, I repeat it again, only that instead of Xa I now use 0 here. From here I have my T to be equals to 1 over 0.4 into bracket minus ln, my Xa is 0.8. okay, and you can get the final answer of your T in seconds. Okay, so you have your final answer of your T in seconds. So this is how you calculate the time for a batch reactor in a catalytic based reaction.